Hi guys, in this video we're going to be learning about standing waves formed in string and pipes, open pipe or closed pipe, and we're going to learn how to calculate wavelength and frequency of the waves formed. Let's start with strings. So let's assume this is a string and someone pulls this string in such a way that the string moves up and down, and in this case if L is the length of the string, and if lambda is the wavelength of this wave formed, then L relates to lambda by L equals lambda over 2. Now you might think, why is L equals lambda over 2? Now let's come over here. This is a wave, a complete wave I drew, and if the wavelength or this distance of this wave is lambda, then this half is lambda over 2. Now if it goes up and comes to the same place from the middle, that's lambda over 2, and you see the same thing right here. You see basically this part over there, and that will be lambda over 2. Now someone can pull it in such a way that rather than just going up and down, it could have two places that goes up and down, and in this case the L relates to lambda by L equals 2 lambda over 2, or it was basically L equals lambda, and you can see why. Now this comes to the same place. You have two bulbs, and in the same way you have two bulbs right here, so L equals 2 lambda over 2. Now someone could pull it in such a way that actually you see three bulbs. This part moves up and down, this part moves up and down, and this part moves up and down, and in this case L equals 3 lambda over 2. Now you can see why. Now I already talked how this one ball would be lambda over 2. Now it has 1 lambda over 2, 2 lambda over 2, and 3 lambda over 2, so L equals 3 lambda over 2. Now you could be pulling string in such a way that you have 3 bulbs, 4 bulbs, 5 bulbs, and just keep going on and on. So for that we can write down L equals n lambda over 2, where n is any number, 1 2 3, just keep going on, 4 5 6 7 8 9, and if L equals n lambda over 2, then lambda equals, you multiply 2 to this side and divide by n on the both side, you get lambda equals 2L over n. And frequency is given by velocity divided by the wavelength. So velocity divided by wavelength is 2L over n, and to finally get this equation, so this F gives the frequency of standing wave formed in string. And let me introduce you guys to some vocabularies. The point in the string that never moves, like this point, this never goes up and down, this and this, they are called nodes. And the point, like point right here that moves the maximum distance, the point right here that moves the maximum distance, these points are called antinodes. And this number n, it's called harmonics of the wave. Now as you can see here, the wavelength that this string can produce while having a standing wave, it can't support any wavelength wave. It can only support waves that have wavelength equal to L over n. And similarly, if it can have only particular wavelength, it can only produce sound, or it can only have a wave with only particular frequency given by F, and the different frequencies are called different harmonics. For example, let's say when we have our n equals 1, then it's gonna make some frequency, and it's called frequency sound, and that sound would be called sound of first harmonics. It doesn't necessarily have to make a sound. That wave would be called a first harmonics. When n equals 2, it would be second harmonics. When n equals 3, it would be called third harmonics. And this string, it can make wave of any harmonics. And there's an easy way just to look at the string and the wave formed and say which harmonic is it. For example, in this case it's the second harmonics, because we can see there's these balls or bulbs. So the number of bulbs in string equals to the number of harmonics of that wave. So this is third harmonics. In the same way, fourth harmonic is going to have 1 2 3 4 balls, and so on. And usually I never memorize this formula, I just know the relationship. just by drawing, and it takes me 10-15 seconds to go from lambda equals 2L over N to this frequency, but you could memorize it if you want. Now let's go to open pipe, and here we have both open pipe and closed pipe. And in open pipe it's open at the both ends, but in closed pipe it's closed at one end. And the way to draw our wave in both open and closed pipe is, in open pipe the end always has antinode and the middle has nodes, and the open part of the pipe basically has antinode in it. And similarly in the closed pipe, the open part of the pipe, it has antinode in it, and the closed part has a node. So for this you have to draw in such a way that the antinodes are always in the end. So in this case you're gonna come down here, go up here. In the second case you have to do like this. Now let's try to draw for this. Now one thing is, you always need antinode on the open part and node on the closed part. So let's draw. So for this case it's gonna look something like this. It's gonna go up and then it's gonna come down. It's gonna touch here and then it just goes to the middle. Again, there has to be a node at this closed end. Let's draw for this one. In this case we just touched the interior of the pipe once. Now in this case we need to touch it twice. So let's do it. 1, 2, and then go up. And for this you just draw the mirror image of the upper wave. It goes here, comes down, goes back here, and that's like a trick to draw the wave. So let's start with our open pipe. For the open pipe, in this case L equals lambda over 2, and the reason it's lambda over 2 is, you can again go over here and see that, so a complete wave is formed. Let's say if we start here, if it goes down and if it comes up to the same height, that would be one complete wave. And if it just starts right here and goes down, that's 1/2 of a wave. And the same thing happens, it starts on the top and goes to the bottom, so this is 1/2 of the wave. So this is 1/2 of the wavelength, and if L is the length of the pipe, then we can see that L equals the wavelength of this waveform divided by 2. In this case, now this is a complete wave because it starts at the bottom, goes to the top, comes back to the bottom. And in this case it starts at the bottom, goes to top, comes to bottom, so that's 1 lambda. And then again it starts at the bottom, goes to the top, so this is 1/2 of the wavelength. So L equals 3 lambda over 2. Now once you know this relationship, you can say that L equals n lambda over 2, where n equals 1 to 3, all these numbers. And again, this is the first harmonics, this is the second harmonics, and this is the third harmonics. And the way you can identify which harmonics is by looking at the nodes in the pipe. The number of node equals to the number of harmonics. In this case, 1 node, this is our first harmonics. Second harmonics, we have 2 nodes, and this is our third harmonics because we have 1, 2, 3 nodes. So for example, in your MCAT, not in MCAT but in your test, your teacher asks, draw a wave in an open pipe at 5th harmonic. Then you are gonna make a pipe, and then you'll have antinode on both ends, and then you'll just try to make 5 nodes in between, then that would be the 5th harmonic. In the same way, if your teacher asks you draw a wave in string in its 4th harmonic, then you just draw 4 balls, and that's it. So L equals n lambda over 2, and then lambda equals 2L over n, and frequency is velocity divided by wavelength, and we get F equals nv over 2L. And similarly, in your test, your teacher might ask you, if the length of a wave is formed, a standing wave is formed in an open pipe, the length of the pipe is 20 centimeters. Calculate the frequency of the first harmonic, then you just put n equals 1 and v velocity of sound, and you just use this formula. Now let's go to our closed pipe, and once you understand one of these, the other are pretty simple. So in closed pipe you will have this L equals lambda over 4 for our first harmonic, and the reason is it's lambda over 4 is, you can see in this case it starts in the middle and goes to the top, so you can imagine as this, starts in the middle, goes to the top, just this part. This is 1/4 of our wavelength, 1/4, 1/4, 1/4, and 1/4. so it's lambda over 4, and in this case, so it starts in the middle, comes back to the middle, and goes down to the bottom. So you can see, starts in the middle, goes to the middle, comes out in the bottom. So it's this part of the wave, and this is 3/4 of the wavelength, right? This part is 3/4 of the wavelength. Now let's go to this bottom one. This is our third harmonics, and in this case, now you can see it starts in the middle, comes back in the middle until here. This is one full wave, and then goes to the top. So it will be 1 plus 1/4 or 5/4, and this is our in this case we'll call them first harmonic, third harmonic, and fifth harmonics. Closed pipe doesn't have any even harmonics. That's what happens. And I wrote it wrong. This should be 1 3 5. So L equals n lambda over 4, where n equals 1 3 5 7 9, and lambda equals 4 over n, and you can again calculate the frequency. Now a teacher might ask you a question like, let's say you have a pipe, you can close its one end or not. If we are having the first harmonics, which frequency is going to be louder? Now you can look at the formula for that. So the frequency of the first harmonics in a closed pipe would be NV divided by 4L, and because you're talking about first harmonic, n is going to be 1. But the frequency of the first harmonics in a open pipe would be NV divided by 2L. So the frequency for a closed pipe in first harmonic would be higher than for the open pipe. In the same way, your teacher might ask you a question like, you have open pipe and a string of same length, both are same length, and both of them are having their in their first harmonics. So which one of the wavelength is going to be longer? Then you can again compare the formulas right here. You have wavelength equals 2L over n for open pipe, and for the string you have wavelength equals 2L over n. So wavelength of string and a pipe of same length, if both of them are in the first harmonics, their wavelength is going to be the same. This concludes my video on standing wave. Please write comments below if you guys have any question. Thank you for watching my video. Hope you guys learned. Bye.